Welcome to today's Research Pays Off. I'm going to hand it over to our speaker today, MnROAD engineer Jacob Calvert.
Thank you, Lauren. Good morning. I am Jacob Calvert. I'm one of the research engineers at the MnROAD facility that was highlighted in last month's Research Pays Off. I will make reference to it a little bit. It's unfortunate that it wasn't recorded, but most of that information is available on the MnROAD website. So if you do have future questions about MnROAD, please take a look at our website. Today, I will be discussing MnROAD's automated distress rodeo that occurred last fall. This presentation, I will give a brief introduction of MnROAD and the distress collection that we do here, which will lead into the reasoning behind putting on a rodeo. I'll briefly discuss the test sections that were used and introduce the participants of the study. I will discuss some of the results from each of the participants and the lessons we've learned from working with them. I'll provide a brief summary of the results, as well as touch on the future goals that we have at MnROAD. I would like to mention some of the future connections that we see as possibilities and discuss the next steps before stopping for questions. Just to give you another brief overview of MnROAD, MnROAD offers a variety of test sections that can be closed to traffic to allow for data collection, including manual distress identification. While MnROAD includes test sections on mainline, old westbound, and low volume road, the low volume road was chosen for the rodeo because it is more easily closed to traffic to allow for data collection. The low volume road is trafficked by a single truck, while mainline and old westbound is subject to I-94 traffic. So in order to close it down whenever a participant would show up, we chose the low volume road. Some of the participants could collect while the truck was driving, and some of them preferred that the truck was not doing laps. Just to give you an example of the test sections that I refer to at MnROAD, MnROAD website has these section maps that are available that will show the roadway, the research study, the section number or cell number, the design thickness for that cell, the installation date or modification date, and the length of the cell. And all of this is available at the link below, or if you search MnROAD test sections. You can also see the test sections here at MnROAD. They are available on our YouTube channel. If you look for the tag at MnROAD Research. We have several years of videos archived, and we'll continue to add more annually and biannually, depending on the test sections. We do collect manual distress surveys, which we kind of draw out on these manual distress maps. And while last month's Research Pays Off discussed a lot of the data collection that is performed at MnROAD, this time we're going to go into more detail on these manual distress maps and the rest of the automated distress collection that is performed here. What MnROAD believes we have to offer to the automated distress discussion as a whole is our manual distress maps and database. We also have additional videos and photo of those test sections so that we can go back in order to check and verify these distress maps. Shown here is a sample of one of the distress maps that will be available online. Distress surveys are generally collected twice a year and will be additionally collected when there is changes in the pavement from accelerated distress or from maintenance operations. The direction of collection is based off of stationing. So page numbers start on the west side of each test section and increase along with stationing. After drawing out distress and making notes, distresses are manually tallied and added to the database. Oops. This drawing is also scanned and added to what will be available online. Currently, We are updating our database interface, and how and where these maps will be accessed is still being rolled out. In the meantime, they can be made available upon request. Our new distress is generally drawn in red. A black and white copy of the previous map is then used during the next collection. We do not redraw distresses each time, but instead append the new distresses to the drawing and to the database. This distress map here also includes the database entries at the bottom of the page. So basically what is happening is one of our engineers is going out onto the roadway, for people who aren't familiar with manual distress maps, and they are walking along and trying to identify every distress that they would see. We use the long-term pavement performance manual, or more or less based off of it. We have made a few modifications over time. Partially, we don't always label all of our stuff as you would see it in the manual. A lot of times we have notes off to the side, basically. So because we're reusing these maps over and over again, we're trying not to write too much on the pavement itself, because as we kind of copy and recopy, those notes that are made on the pavement tend to get distorted over time. So you may see and you may notice that there's a bunch of lines without much indication as to what they are. Usually there are some notes on the side of the page that will indicate what they are. Generally, anything that is just drawn is low severity, and our moderate and high severity is then marked as such. But basically, we have people taking a lot of time walking and rewalking these sections to identify any new distress that then gets appended onto the old tally. We can use the tallies on some of these sheets is added to the bottom. And when I kind of mention these tallies and database, this is the list of database entries. In this case, it is the HMA database entries, where it covers the different types of distresses that we see, the levels and severities of those distresses, and tabulates them by either their number, area, or length, and sometimes both. We do separate out our sections based off of lane, so there is an indication as to which lane the collection is taking place. We have a similar database for PCC, or Portland cement concrete sections. Additionally, we do collect automated distress. Um, MnROAD has some experience with automated pavement distress surveys. MnROAD operates one of the same vans that's used by MnDOT Pavement Management, that they use to rate all of the state and local highways throughout Minnesota. And as pavement management replaces vehicles in their fleet, we're given the option to possibly upgrade our van by receiving one of their retired vehicles. MnROAD then uses these vans primarily to collect ride and rutting information that is added to our database. In additionally to adding this stuff to our database, it does allow us then as well to collect data the same way that pavement management is producing data, and we are able to analyze it in similar methods to hopefully get a correlation. Um, Previously, the vans had macro texture lasers, and it's no longer included on our current van. We primarily use these vans to collect ride and rutting information that is also added to our database. And while it is collecting ride and rutting, it also can identify and classify distresses in the pavement. This photo of our van um, there highlights the laser array that is attached to the back of the van. More information on the van is included on our website on the link below. Those lasers on the back of the van produce data. that along with the forward-facing cameras mounted on the roof of the van are used to create kind of the data set that's shown here. After collection, data processor is able to use the forward-facing perspective camera, the angled shouldered facing camera, as well as GPS coordinates to determine the location of the van in the collection. The van also measures distance while in motion to provide stationing. The lower laser on the van calculate the ride for both wheel paths, and the upper lasers and 3D camera um, provide line scans that can produce these transverse and longitudinal profile information. For distress identification, we're most interested in the center of this data array that shows the 3D laser scans. A 3D camera collects the intensity of reflected laser and the length of the time the laser traveled. This timing can be used to calculate the height of the roadway at that laser point. These scans can then also be used to identify distress in the pavement. There we go. So when you kind of focus on that intensity and height line scans, the changes in intensity allow us to see the changes in the pavement surface. Most notably, the paint lines can be seen, and here the sealed cracks as shown in this image. Distress data is then identified by software and further classified into distress boxes shown above. And you can turn on and off the distress boxes. So in this image of height, I have added the distress boxes. In there, you can see kind of the pink distress that's inside some of those boxes, and then the classification gets color coded. And here it's blue and green for transverse and longitudinal. It will also change the severity as well. Where And at this point, I want to give a resolution disclaimer that will cover all of the previous and additional slides. The resolution that is produced by this particular software, as well as the software from our Rodeo participants, is not possible to reproduce for an online presentation. For instance, the scans shown above are set to display 50 feet of pavement to match our distress surveys. You will notice distress boxes on the right that do not look like there's any distress there, but when viewed on a smaller scale, higher resolution, and on the original screen, they are much more visible. And that is true for a lot of the photos I will show from our participants as well. It may not look like it's super high resolution, but it is kind of similar. The YouTube videos that we show, the resolution gets downgraded to YouTube. And so if you need higher resolution videos, we do have those stored and can make them available. That being said, we did notice even at that higher resolution and zoomed in, um, the automated distress tallies we were receiving did not match our manual distress. The pathway software allows the operator to manually add distress. So we compared our manual distress maps to our automated collection, which is what you see on the screen here. We're basically able to take um, those images, split them into 50 feet and compare them one-to-one with our distress maps and zoom in on the locations where we know that there's distress and see if we were able to spot it. Um, the results of one of these comparisons kind of shown above, where even zoomed in at our highest level, we were unable to identify all of the distresses, and some of the most commonly missed distresses were these low severity longitudinal cracks highlighted here. It's worth noting that we also have issues with resolution on our manual distress maps as well. As I previously mentioned, we were creating a copy of a copy, and occasionally the maps would need to be updated in order to clean up that created noise. But we could even as such, we could still end up with some pretty messy um, outcomes. This worked well for the person rating the cell because they were able to kind of read their own handwriting, and were able to create the tallies, but they don't present well to an outside audience. So if someone is asking us for distress surveys, um, we'd like to get things cleaned up a little bit more on our end as well. So we saw a need for improvements in both our manual and automated distress technologies. Um, So we were trying to look at how can new technologies be utilized to improve or replace manual distress surveys. Um, Looking to focus on field data collection and data processing, where MnROAD would supply the test sections, a distress data format, and an online platform for participants to share data. MnROAD would provide a summary of the different collections methods with the goal of providing details that would allow future users um, to decide which techniques would be most suited to their needs. This is where again, I have to be careful when I say, improving or making things better, in that for some people, their need may be along our lines where we're looking at research. So those minor cracks are very important for us to keep a full picture of what's going on in the pavements. But when you're trying to collect the entire state and you need to process all of this data in a timely fashion, you may not be interested in seeing all of the small cracks. So depending on what you're looking at, you may um, believe one thing is better than another. So we aren't really trying to say which one is better, but just say kind of the differences that we noticed in these techniques. So 8 sections were chosen from the low volume road, 4 hot mix asphalt or HMA sections, and 4 Portland cement concrete or PCC sections. Each of these 4 sections would have 2 relatively low distress and 2 relatively high amounts of distress. Additionally, sections would be chosen or truncated to allow for lower amounts of sensors, forensic core holes, and other artificial distresses that can be caused on research sections. One lane was chosen and is highlighted in the graph above. Our distress surveys generally include both lanes, but for the next slides, I've trimmed them down to the lane that was used for the rodeo, and included blue arrows to show the direction of traffic. Just to give you a quick overview of these sections. Um, And to assist in collection, you'll notice that we do have 2-foot grid line squares included. Crosshairs were used to prevent that kind of, if you saw on the previous slides, the grid lines that we try and use tend to darken over time as we scan and rescan. Stationing is included at the top or bottom of the drawing, with a scale of every 10 feet. This is HMA1, which is 198 feet of low distress HMA that was installed in 2017. HMA2 has a higher amount of distress. That was 225 feet of hot mix asphalt that was installed in 2008. And here's where we can start to see some of that fine cracking that we're looking for with the fatigue cracking and raveling. HMA3 was another low distress HMA where this was a 2021 overlay. Most of the distress we're seeing is just reflective cracking. HMA4 is a high distress cell, 300 feet of highly distressed HMA that was actually um, replaced at the end of last year. Um, Due more to the inside lane, which is the more trafficked lane, really needed to be replaced. PCC1, this is just one of 2. Again, there's 50-foot sections, so we need a lot more distress pages for 480 feet of kind of a low distress PCC, which was installed in 1993. PCC2 was 240 feet of low distressed PCC, installed in 2017. PCC3, 198 feet of more highly distressed concrete, installed in 2017. And PCC4 is more highly distressed concrete installed in 2000. And you may notice, especially in PCC1 and PCC4, that there's a significant amount of sensors and forensic cores that had been added over time. And while we tried to avoid this as much as possible, they're very common features at MnROAD, and it's almost impossible to entirely avoid a lot of these additional um, adaptations that have been made over time. So the participants for the rodeo, we were from MnROAD, we were going to include the manual distress maps that we have created. We would provide collections from our MnROAD high-speed profiler. I say Pathway Services is the van that created that. They produced the software, but it was all internal processing that was done of both the collection and the data. Um, MnDOT Aeronautics agreed to bring out their drone and do a LiDAR collection. We had Terracon and Pave AI come out and try out their equipment. Transconomy and we had saved data from the Australian Road Research Board's Intelligent Pavement Assessment Vehicle. They did not participate in the rodeo, but we were able to kind of go back and spot check some of their stuff. Unfortunately, we were unable to work out the timing for automated drone flights. We were hoping to get some collection done there, but it didn't quite work out with our schedule and the participant schedule. We attempted to make our own collections with a GoPro and a newer 3D collection system from Pathway Services, but we weren't successful in those efforts. So to cover MnDOT Aeronautics, MnDOT has an unmanned aerial systems unit, and they also operate the drones out of MnDOT Land Management. In this case, they can produce LiDAR data collection for us using a fully automated flight path. The LiDAR additionally collects data outside of the roadway. So they had previously used this unit for checking some of the geotechnical work around the MnROAD site, but we were hoping to really focus that down on the roadway and collect information, kind of a highly resolution information for use uh, both by us and by outside people if they requested it of distress in the roadway. Put it this way. Terracon, Pave AI, they had their video collection is basically um, a unit hooked up to an SUV really and is connected to Pave AI, where they're able to upload the data from the vehicle, from a cell phone in the vehicle to Pave AI. Pave AI performs the data analysis. Transconomy, similar SUV vehicle where they're collecting data from video devices on the front and back, and it looks like a 360 camera on the top of the vehicle. Transconomy, um, if you go to their website, it appears they do a lot more with some of the pavement management and asset management. So a lot of the times these vehicles are used to collect information on road signs and things on the shoulder, but they are using their machine learning computer vision technology to test out what they can do on pavements. As I mentioned, AARB's traffic speed deflectometer was out here in 2019 and 2020. Their data was still accessible on Hawkeye Insight. And so we were able to look at some of the older distress maps that we had and kind of just do a quick comparison. Um, this is predominantly used for state road authorities and has been used on some government networks too. This unit that you see here, iPay vehicles can also be used to measure roughness, texture, rutting, digital imagery for visual rating, and automated cracking. So this is one of the larger units primarily used as a traffic speed deflectometer that they've added all these additional things onto. So getting into some of the information that was produced, unfortunately, with MnDOT Aeronautics, our first data collection was not performed at the highest resolution. They it was probably a miscommunication on my part where this is new to them. They do a very minimal amount of roadway distress collection. So for them, this was as much of a learning experience as it was for us. And so they could have performed the distress, but they really wanted to get a higher resolution imaging. So data was recollected in December, and we still need to work on processing that. We hope to um, get that processed just to see how their algorithm works and then to see whether we can make that data available to others in the future. Um, they were able to provide us TIFF files that can be brought into Google Earth. And so that's one of the ones that you see here is where they're able to um, give us these resolution photos. And again, because of the resolution, I'm not certain how high resolution it can get. You can see some of the cracks if you kind of zoom in on that overlay, but we're really going to focus on narrowing that down to see how high of resolution we can get. Again, Pave AI. Um, They actually came out here 3 different collection dates. They did a full loop back in late 2022 just to demo their product and process, and we invited them to come back and participate in the rodeo. And we were hoping to get kind of 2 different collections from each of the providers just to see how repeatable their process was, but that didn't always happen. But Terracon was great to provide us with at least one section that was repeated twice. Um, and so in those different data collections, there was a different level of processing. The first time they processed the entire loop. Second time they only processed those eight sections for the rodeo, and the third time around they just did 2 sections just to show the repeatability. Now, generally, this product is marketed at a project level. It's used primarily, my understanding, by Terracon for parking lots, where they are producing a pavement condition index, and that they can then visually display over these orthomosaics. It's not currently set up to output database entries, and then they are currently including some manual identification in the process. They were basically pitching this as a possibility for us to explore. This isn't their normal market. They aren't normally doing roadways, but they were very generous to try out their product and kind of show us what they could do as far as presentation and identification. But however, because that kind of gave things in a PCI rating or a pavement condition index, we weren't able to really compare that as well to our uh, database entries. So this was a learning process for me where I basically looked at how, like I said, pavement management van were able to somewhat reproduce what pavement management produces. And I say somewhat, so this is not entirely what pavement management does. They produce a lot of things, and I'm only touching on one. Um, But one of the things that they do, and you can see the rest of what they do on this link here, is produce a surface rating, where they're looking at the distresses measured. They're taking those distresses, weighting them by multiplying by a weighting factor, adding it all together, and then using this calculation to perform a surface rating. So I wanted to compare Terracon's PCI to the surface rating that we would get if we plugged in our numbers. And so here's a quick graph just to show the PAVE AI produces a PCI, which was on a scale of 0 to 4, and I overlaid that with MnDOT pavement management van rating, which was on a scale of 0 to 100. And then I added our surface rating that we can approximate from our manual distress data. It's can only approximate it because we don't do all of the measurements specifically. We aren't out there calculating rutting, but we can enter in what we have. Um, there's also a few changes in how they calculate things where they are using number of they're for concrete they're using number of panels, and so kind of getting percentages based off of that, which isn't always something we have in our database, but we can go back and relook. And so here you can see the HMA sections 1, 2, and 3 compared very well, and PCC sections 2 and 3 did not compare well. So we wanted to kind of look into whether it was just a change in the PCI to surface rating. And because they are calculated, basically that PCI rating, um, or actually the surface rating was highly weighted towards spalling. And so when we put PAVE AI's information and again get that similar approximation, we're able to reweight that spalling, and you can kind of see that PAVE AI was able to more closely match the MnDOT results. One thing I forgot to mention on this slide was we were happy with PAVE AI, where they were able to get the trends, where we kind of expected to see higher PCI ratings for HMA 1 and or 2 and 3, um, and lower PCI ratings for PCC 3 and 4. What kind of surprised us was that low rating for PCC 1, which occurred in our structural rating, but did not occur in their pavement control index. Um, and we're kind of wondering that HMA 4 had a little bit of difficulty. We wanted to look into that a little bit more closely. So after looking at the structural rating, um, we did look into some of the presentation, and as you saw before, um, Pave AI was able to present this data really well. You saw the ortho mosaic that included the entire low volume road. And in that, you're able to zoom in. So here you're able to kind of see and zoom in, and you're able to see the distresses that they labeled. And some places they had a um, little bit of discrepancies between what they labeled and what we labeled. But in some cases the presentation is better than our distress surveys, or more truer to the actual crack than our distress surveys, which is kind of shown here for HMA3. Um, then we're looking specifically at that um, HMA section where we had some issues and said, hey, we think that there was some more distress that should have been showing up and lower their PCI score. Here you can see HMA4, and where I was looking at it, I began to wonder, from what you can see on the image on the left, from our drone videos, again, resolution disclaimer, but you can see more of the distress. This was collected on a different day, but you can start to see especially why this section needed to be replaced. However, when they did their collection, the road was definitely dirtier, and so that also can affect how um, our van will be able to collect the data. And so we do get some days where we're able to see more cracks than others. As it turns out, in discussions with Pave AI, they on this particular collection day they had an issue with one of the passes. They do multiple passes on the roadway, and the one on the shoulder had a little bit of difficulty, and so they weren't as able to get as high of resolution um, as as they wished. So that was one other issue that they had. And so here I just show you those collection conditions where between adding a second run and just having a better day to collect. The collection on the right, you can see it would be a great day for doing manual distress surveys because there was some moisture inside of the road, but not on the surface. And so a lot of those cracks really pop out. And in addition, Pave AI had an additional scan on here, so they were able to produce higher resolution images. That being said, I think if they had rated HMA4 on their second collection instead of their first collection, they would have had a closer outcome. Just again to highlight some of the benefits of their system compared to our manual distress maps. Here you can see the highlighted distresses, um, and you can see kind of my drawing down at the bottom. And some of their cracks show a truer representation of the cracks. What they also do well is it's a photograph, so you're able to see those paint numbers that we put on the roadway, and they did a very good job of not picking those up as noise. Sometimes the automated distress systems can pick up those additional markings we have on the road, and try and classify them as distress, which is another reason why we wanted to do this rodeo, was to improve that technology. You can see there's a few things where some of their joints, the stitching the orthomosaic, again, probably will be improved in the future, but we're very happy with the the steps that they're making in that regard. Transconomy, moving on to Transconomy, again, they had another similar vehicle with the videos on the front and the back. I was not able to see their distress output other than they very kindly sent us their um, database. So in this case, I was able to make more of a comparison between the two. And here, just rather than going into all of the details with the numbers, because I still need to work with these a little bit more myself, you can really see that there's lower detection in these distress sections 1 and 3. So when I kind of remove most of the null, you can just see there is more detections in 2 and 4, fewer detections in 1 and 3, and you can kind of start to compare those numbers. They compare they compare very well to the pavement management van and the manual distress survey. So here you can see Transconomies on the left, the pavement management van is in the middle, and manuals to the right for all four of the HMA sections. A few things that we did notice, um, that Transconomy and um, our pavement management van had, and honestly, we had some discussion with our manual distress surveys, is when we are only rating one side of the road, what happens to the center line joint. And so here you can see the picture when that center line joint is on the right hand side of the road, and we're rating the left hand side of the road. Where do those distresses count? And so this can be one of the things that really kind of needs to be solved with um, firm distinctions in where you are rating, and how you are rating, which is some of the discussions we will have. Um, but then also distresses can be missed. If that line detection is picking up the edge of the cell on the inside of the line, you may never see those joints. Wheel wander. If the vehicle moves over too far, it won't pick up those center line joints, and also it can be masked by cracked paint. It isn't all they aren't always easy to see, especially at low severity, which is again one of the things we're trying to pick up is really these low severity cracks that may or may not be an issue, but we want to be able to count them. And so I was able to graph a little bit of the results. So here you see transconomy, where I was graphing the number of cracks with the length of cracks and really comparing their sections with um, the manual distress surveys. And um, there's a few discrepancies we can kind of see in PCC sections 1 and 2, which may have been more of a classification thing where I classified them these small cracks as block cracking, and they appear to have labeled them as longitudinal cracks. Again, here we see where I removed the null just to show um, the the quality rather than quantification, I guess, where you're really looking at here's the low distress, and you definitely see it's picking up a lot less distress than the higher distress sections. Um, One of the things we noticed, skipping ahead a little bit, pop outs, where these automated distress systems, this is one of the things where we can say, hey, these things are much better at identifying and quantifying, because as you can see there are 219 pop outs, where we won't we just don't have the time to count all the pop outs. So for me, I would just say, hey, there's 8 panels with pop outs in them, but they're able to actually pick out a lot of those pop outs, where I can't even, well, I could, if I spent a lot of time, kind of check their math on that. Um, Still, some of the issues we're seeing are these transverse joint seals, with both the van transconomy. Um, I think Pave AI as well, where it's just, and maybe it's the sections need to be labeled better, whether they're sealed or not sealed, but we are having some difficulty picking up those. I know when I'm adjusting them, it's really difficult to see on the screen what is where seals are having distress. Transverse spalling, also one of the issues that we're looking at hopefully improving in the future. And they were able to pick up a lot more polished aggregate, which I still need to further investigate. I know PCC4 had been ground, and so there was a lot of exposed aggregate, but I'm not certain that there was the traditional polished aggregate. But definitely they're picking up on that a lot better than I did with my manual distress survey. So that's one of the things I still need to check into. Here we'll just give you a quick overview of ARB's traffic speed deflectometer. Again, wonderful presentation of the data, where here you can see the Hawkeye Insight web portal allows to see the vehicle's location, the different camera angles, and the cracking data. Very similar to what we're seeing with the pathway van. Um, what's great about this is they're able to, you're able to move that slider seen on the previous screen, and it shows the cracking data at those points. And then you're able to move this little slider up at the top that allows you to pick the different dates of collection, very similar to Google Earth. There's slight offset, again, very similar to Google Earth, but you're able to see the kind of crack propagation over time. And we're seeing, at least in my opinion, I'm seeing very similar detection to what we get with our van. Again, we're trying to pick up those low severity cracks. Again, just to show you HMA2, trying to improve that crack detection here. We had a crack that we found in our manual distress surveys in 2015. Here it didn't show up in 2019, but they definitely picked it up in 2020. So just to summarize, manual distress surveys are still the standard that we're going to go off of. Um, However, very good results can be obtained with a variety of collection devices. I mean, you can see this scaled from a
You got muted somehow.
all right.
There we go.
Okay, good. We're back. All right. Um, Now I gotta get my presentation back up. All right. So, yeah, good results can be had for a variety of costs and effort. Um, and what we see, I didn't describe this much in the presentation, but automation does provide a safer and faster alternative. It is a lot safer to be looking at these cracks from your computer screen than from out on the road. Digital results provide a truer representation, as kind of shown again on the right, where you can see you really see what the crack is as opposed to somebody's rendition of it. The presentation of these results can be enhanced with these digital add-ons, again shown below, where you're really able to increase the usability of this data. And then, of course, depending on, on what you put into it, the additional data provided by these vehicles. So you can just go out there and collect just distress data, or you can collect all the additional data, rutting, ride, TSD, as needed. Future goals. Again, we're trying to help out wherever we can to improve this resolution. As you can see again, um, from the show from the photos on the right. But we're also trying to learn. So how do we tailor our or MnROAD data collection? So as I mentioned, we're working with aeronautics. How do we produce LiDAR data that other people can use? One of the goals of the distress survey was to get people who just wanted to process the data, not collect it. We didn't have anyone participate in that. We have had since then requests to use some of the data for similar operations, but our data um, isn't tailored to their needs. So we're really looking for people who want to process this data to give us advice or to ask us, hey, can you have your drone or your vehicle or your GoPro do this, so that we can produce that data, save that data, and share it with whoever wants to use it. We do want to try and work on this automated drone collection, so we can have that capability to really do more of the project level, so the smaller areas, more higher resolution. We're working on that LiDAR collection and processing. And again, as I said, increased participation. So we'd love people to come and help us out, and allow us to help them wherever we can. Where we kind of see some of the future possibilities, is this possibility of quantity over quality, where lower cost, more vehicles, where you might not be getting as great of data, but you are getting more data. This is also kind of decoupling some of the data. So right now we're using a pavement management vehicle that works great for doing the things that pavement management needs it to do, in addition to doing distress surveys. And so we're wondering if we decouple that, and can we get a vehicle that's lower cost, that doesn't need to do all of the pavement management stuff, that can just do distress. And so there are these places, and here is just an example of connected vehicles where they're kind of using fleet vehicles, or in some places people are trying to use phone data to really crowdsource ride data. Um, And so, in addition to kind of crowdsourcing, there's this cloud sourcing idea, where you're moving from PC computing to cloud computing. One of the nice things about our pathway software is that it fits on a program that we can share with people, so researchers can look at our data from a laptop. Um, However, one of the as you can as can be attested by Pave AI and Transconomy, they're moving more to these machine learning and AI programs that are able to bring a lot more computing power to this identification. And we really see that as a way to further improve these systems, where especially if you're able to collect more data from more vehicles and get it into the hands of these larger computers. So in this case, you'd have more specialized computers than specialized vehicles. For more information about um, the quality of pavement surface distress and transverse profile data collection, there is a transportation pooled fund study. We were able to get some advice about our study from them, but we as Minnesota are not participants in the study, but I want to give it as a reference in case you are more interested. Um, the future goals here at MnROAD, we'd like to further improve MnROAD's manual distress surveys, the collections and the presentations. We want to continue to offer MnROAD data and test sections to anyone who would like to use them. And then we're looking at questioning whether future test sections um, what else can we offer? So do we need test sections that include distress panels? Kind of the idea being, should we do high resolution scans of distress sections that are here so we can really dial in these procedures to see if they can pick up the smallest cracks? Or do we need to produce panels that can be removed or protected to use in the future? So similar to these lines here, we would just produce a bunch of cracks on a panel and see whether these technologies, which cracks can they pick up and how fine of a crack are they able to detect. Where here we're using the roads, would we need to protect those? Would we need to put it on a section that isn't trafficked? And so that's kind of there. Is there a need to save additionally some of the highly distressed test sections? When a section gets old, it needs to be replaced and new research put in. If all of our research starts at the same time, we end up with a whole bunch of really nice concrete sections. And so we're trying to figure out how do we maintain a balance of available distresses if people want to come out and try out their products. With that, I will take any questions.
Thanks, Jacob. We do have one question in the chat from Tom. Should we require cleaning of the surface prior to testing MnROAD test sections? And I think that's when you were discussing that some of the paint and debris on the road can sometimes alter the results. So that was one of his questions.
Yes, and unfortunately, we tried we tried to clean some of the sections, and as you can see, one of the additional issues we had was what do we do with the grass that's growing? And I actually had some conversations with pavement management to see. Um, yeah, but I was out during the rodeo. I actually started paternity leave a little bit earlier, so we were kind of hoping to be able to sweep these off and get things clean, but we weren't able to coordinate it. However, some of the stuff, as you might be able to notice, like that section was pumping. And so a lot of that stuff was coming up and would be difficult to clean. Again, if we wanted to do a more exact, then yeah, that's part of that question is, would we need to vacuum truck off all of these sections each time someone did it, just to give an exact, everyone have exactly the same test section. We tried to compensate for that by getting everyone to collect at the same time. but schedules didn't really allow that to happen.
I will invite you all to, oh, I do see a hand from Bernard. Go ahead, Bernard.
Yeah, can you hear me?
Yes.
Yes, I can.
Oh, great presentation, Jacob. I wanted to ask you, was any of the participants, was there any of the participants in the rodeo who was interested in actually looking at how their product arithmetically compared to our ground truth? I'm imagining our ground truth now to be our manual distress survey or the payment management van. I am saying this because if that's something we need to do, so we start to do it early in the game. If you have a total length, let's say total transverse crack length, to what extent does that match the total transverse crack length in the ground truth, even if the numbers are close? Because you have some cracks veering off at a certain angle and some oriented in it, but somehow at the end of the day, you have numbers that are close.
Yeah.
But in a situation that's laid out for a process like a confusion matrix, then we're able to see arithmetically the degree to which these new methods compare to ground truth. I mean, is that something you are thinking about? Or?
Yeah, and so we did provide all of the participants with our database numbers, and you just saw a brief example of comparing a few of those numbers. However, yeah, that is one of the things we're looking at is how exact do we want our numbers to be, and so what Transportation Pooled Fund, their suggestion was to get one of these higher resolution actually scan out here from a company that does it for warehouses or something like that, to give us a super detailed rendition of at least a small section to see if they wanted to. At this point, a lot of people are trying out their software, and so no one was asking us for super high resolution images or data at this time. I know if we wanted to put the time into it, we could be trained by NCAT does a system where they're out there with their GPS, and they're producing these orthomosaics themselves, and they can put distress into AutoCAD at a very highly detailed, where you would be able to get a better representation of crack length and stuff. At this point, nobody was asking us for that information, and it would be a larger effort on our part. But when people start asking us for that, we would be interested in doing it.
I'm thinking we should preemptively probably do like a confusion matrix and have that on record, because all these methods are coming in, and I'm glad we're addressing them. I'm glad you did the rodeo. We are looking into them, but we also need to establish these ground truths, more of the ground truths than actually let's say, these laser point specificities of the results, but seeing how they really, really compare to ground truth. That will give us the confidence level we need to further our path in this direction.
Yeah, and that is, again, we need to work a little bit with the Transportation Pooled Fund study, because I know I believe they're working on some of that as well, or at least trying to define how that will be done and levels of success there. We really don't want to try and duplicate their efforts, but I completely agree with you. That is something that we want to look into.
We have another question from Surya. What are the costs involved?
I didn't go into the costs just because, again, I'm a little bit behind the game from that paternity leave extending. where again, I think it will depend on the level of processing that you want. And so from our end, obviously, the more details we get, the longer we put into it, and that would raise the costs. But I didn't have time to parse out each individual cost. It's on the list of things to do.
And then Jonathan from Transconomy just wanted to add in that they are planning on doing this arithmetically using the ground truth data.
Yeah, and Transconomy was one where I sent them the results and have not had a chance to meet up with them. I was able to kind of discuss some of the results with Pave AI. I'm looking forward to that conversation with Transconomy, just to understand a little bit more of what they were seeing to help us with our manual distress maps, but also hopefully we can provide some information to them to better improve their processes. So yeah, if Transconomy, Pave AI, Terracon, AARB are listening, or MnDOT Aeronautics, again, thank you guys for the information. I'm sorry that it's taken me as long as it has to get you guys some of the information that we promised, but we will continue to try and produce that. Dr. Congress, we're hoping to see you out here. We'd still like to try out your stuff as well.
Absolutely. I look forward to it, Jacob. Thank you.
Any other questions? We are a few minutes over, so if there's nothing else, we can wrap up and let people go for the day. It does look like a few people have had to leave, which is totally understandable. I'm not hearing or seeing anything else. So with that, I think we will conclude for the day, and thank you all for joining us, and thank you, Jacob, for your presentation.
Yeah, you're welcome. And I want to make sure to say thank you to Pavement Management too for their support and helping me learn this process as well.
Thank you all. Have a great Tuesday.